everyone. Welcome to our event about the space. Today we are going to discuss about model rocketry and rocket science with our special guest who has worked in different companies, space companies, and who has been a volunteer in NASA for over 4 years. So before starting, let me introduce myself. I am Burak, and I have graduated from mechanical engineering department from Truck University, and we are currently working on model rocketry. And it all started via Technofest, which is technology festival in Turkey. And in the first, we built model rockets, and it's launched and reached 3,000 meters from the ground. Right now, we are expanding our teams and giving lectures to new member. Our team is located in a community uh, whose name is ITDC, which is the interdisciplinary technology developing community. And we have a different type of teams, such as robotics, model rockets, jet motor, and biotechnology. So this kind of community helps you to understand more about other technologies rather than your special department in university. So, for example, I was in the model rocket team last year, and I helped the biotechnology team. So we work together and build their model. So it's a great opportunity for people to learn more about technology, especially for students. So today we are going to discuss some topics about model rockets and some popular uh, topics about rocket science. So in a live stream, my friend is going to help me, Ali.
Hello, everyone. I am Ali, and I am a student of Truck University, and my department is mechanical engineering. I were one of 6 friends at our rocket team, and I am a coordinator of avionics and ground systems. And I just want to say thank you to Robert for accepting our invitation. And I will be waiting in the background. And if there is any problem, I will be help, and I will help. And I wish you a good stream.
Thank you, Ali. So let's have the Robert. Hello, Robert.
Hey, how's it going?
Good.
I
What about you?
Good. I was just gonna apologize off the bat. I have a little bit of a cold that I'm coming out of, so if I sound a little off or something doesn't come through right, just be sure to let me know.
Yeah, I can hear you perfect.
Okay.
So I just want to start with your background and what are you interested and what are you exactly doing right now? Can you tell us about them?
Yeah. So I currently work at Kennedy Space Center. I have, as you said, for 4 years. My background is aerospace engineering, so that's my major from university. And then we had 2 tracks for that. One was a propulsion track, which was more focused on jet engines and aircraft, and then the other is a space one. So I went the space track. Um, and I work on the Dream Chaser space plane right now, and then I worked
Okay.
on the Artemis program for 3 years, almost 4. Um,
So what I'm curious about is that your job in NASA. So what are you doing exactly in NASA?
so in the past, I worked on the SLS program. So it's uh, the human launch system to carry humans to the moon and back. If you're not familiar with the Artemis, it is a program, international global program, where it's an effort to go back to the moon and to stay. So the whole idea is to set up infrastructure like we have on the surface now, like metro, power plant, um, communications, all of that, so that when you're staying there, you don't have to continually bring everything in one go. And one of the pieces of that plan is the SLS rocket, or Space Launch System, which is a
Yeah.
very creative name. But they build it in separate pieces and ship it to Kennedy, and then it has to be assembled. So my role was an operations engineer, which deals with the assembly and integration of the vehicle. So all of the separate parts arrive and then have to be assembled together. And there's procedures, processes, and a timeline, of course, because everyone has a big schedule and a due date, uh, to where all of that has to kind of happen, and it's a lot to manage. So they have different people to manage different parts of the operations, and um, I would work towards trying to streamline some of those operations and figuring things out. If you want, I can do the presentation, or we can keep going like this. By the way.
So, Ajay, I will want you to share the presentation. But
Okay.
first of all, so it's so exciting to be a part of a new technology stuff. When you go to another planet, and as you said, you have to come back, and as I understand, you're working this kind of stuff, and so it's so exciting about going another planets. So let's continue with the next question. So,
Okay.
I graduated from the university, as I said, and uh, for example, if I want to be a part of a NASA, how can I volunteer for NASA?
So NASA, as like an organization, is really interesting because it's kind of part of the government and kind of separate at the same time. So all of the government roles are required to be like U.S. citizen. So that's like a big block to people a lot of the time. But the way NASA tries to make things work, involves a lot of both outreach, so things like this, where it's just talking, but other things too, where it's like creations of challenges, um, technology demonstration, grants and awards. So it's still possible to work in on things that are more public and outward facing, where they want to see proposals or papers or concepts for how to use the things that they have. A lot of the time, they'll have a um, a proposal go out where they want to see um, specifically university level research on all sorts of different things, and um at a university level, you can even do work basically that goes in towards NASA and kind of runs into this whole system. On the other end, too, because like I said, Artemis specifically is a international program. ESA is one of the big partners with us. So the European Space Agency helps um, provide our service module. So the service module helps get the crew back from the moon and maneuvers the spacecraft around in lunar orbit and on the way to the moon. Um, so there's a lot of work there, basically, that goes into making sure that all works. There's several other European contracts for like the international habitat, which is going to
Mhm.
go on the gateway for Artemis. I think that was just talked like last week or the week before, with the mock-up of what they think it's going to look like, and that's going to be a great effort because that's much like the International Space Station. The Lunar Gateway around the moon will be a space station made of parts from international partners. So uh, everyone kind of gets to add a piece, and it gives everyone a stake in the program, which is great because for one, it distributes the work, so no one has to like do all of it. Uh,
Yeah,
and then it also distributes it in a way that uh, everyone gets to be a part of it, which is like it's hard to kind of put into words, but the pride factor is very big there, where everyone wants to have a role and say that they contributed, and there's a lot of that. And then finally, I'll say there every SLS rocket has a section on it that has CubeSats. So there's multiple CubeSats in a ring around it, and all of those are a part of the Artemis mission as well. And those do different roles too, like finding water on the moon. One is testing a landing demonstration. That one's actually made by the Japanese Space Administration. and a university, and then we have a few other university ones, and I think one European one as well. Because way back, I used to work the plan for getting all those people into the building to put their satellites in the rocket, and they actually are now loaded into the rocket and in testing to make sure that they're ready to fly.
Oh, okay, thank you. And I just saw a photo in your Instagram page that you were standing in front of the rocket. Is that from Artemis?
Yes. So that's the Space Launch System. That is, looking at the calendar, I think about 3 or 4 weeks ago, I got really lucky and I got to go um, into the building and onto the platforms. So I actually have some other photos, but I haven't gotten approval yet to send them out. But seeing the European service module and standing next to it, which we like in engineering, we usually see it like in a CAD model, on a screen, or a
Yeah.
PowerPoint presentation with like a picture. So it never really, the size doesn't come across. But when you're like standing there right next to it, it's like, wow, this thing is very large. Um, but I worked a lot of stuff on the program and everything, and I was able to reach out to some of my contacts who are like a lot higher than I ever was, that could help me, and they took me on like a very like special tour. Even the people in the building were like, how did you get to go in there, and how did you get like photos, because the area around the rocket is as restricted for electronics, so you have to leave your cell phone, your car keys, your smartwatch all at the ground, in the little bin, and then go up, and then you can go see it. But we got a special camera to
Yeah,
do it.
like going in a soldier area.
Yeah. Um, it has to do with like the explosives in the rocket,
Yeah.
because it's um, if like a radio signal were to be just right, it could like send to the rocket and then tell it to like deploy something. Like one of the CubeSats just pops out, that would be like a really bad day. So to be really careful around spacecraft, a lot of the time they have like a drop box for putting all your things in, and then you can go in.
Yeah. Also, yeah, I can understand. When we are building rockets in a competition, uh, in an assembly time, we used to recharge ourselves if some electric, no, a static electric occurs.
Hmm.
So I can understand. So, and
Yeah.
the other thing is that I can imagine how big the real life rockets. So we actually built a rocket which is 3 meter long, three
Hmm.
meter high. So it was big for us, but I can imagine how the real one is exactly.
Oh yeah. And that was a first for me. I haven't built anything even that big, so that I consider that impressive too.
Thank you.
So don't downplay that. Just because 3 meters of something flying is pretty large,
Yeah.
um, to where it's when you see something like like Space Launch System, it's like that looks like a building. I can't believe that's actually gonna go anywhere.
Yeah. But unfortunately, in the competition, we attend to the final part. But as I said, it launched and reached 3,000 meter. But unfortunately, the deployment system didn't work exactly what we expected. So the parachutes didn't opened, didn't
Hmm.
open. So we couldn't save the rockets. So it was a little bit disappointed for us, but we recorded the video that rockets was launching, so it was a great thing. It was so excited.
Yeah, if you get that far, it's honestly just great. The deployment systems always are a challenge. I know, um, in my university team, I didn't ever get to see it fly, but the one I was working on right before I graduated, it ended up having the same issue where it went up and it came down very, very fast.
Yeah, yeah. I can imagine. So I just want to continue with the model rocketry questions. So if you want, you can share your screen
Oh,
and
sure.
we can talk on them.
Do you want me to move to that part of the presentation or?
Yeah, yeah, please.
Okay. Um, share screen. I have it up, so it should come through. So I'm just gonna fast move through this real quick. Okay.
Yeah, here is it. Here it is. So my first question is that what was the inspiration for you to start the model rocketry, and when did it exactly happen?
So I was always really interested in like space and rockets and everything. But as it says here, we had a um, summer camp actually at our local public like science museum, and the summer camp would be like a week um, out of the summer where you could go and with kids basically go and build a rocket, fly it, and then
Yeah.
take it home. So the whole week would be building a rocket from a kit, just something small basically, with little balsa wood fins.
So
And
it's used. I'm sorry to interrupt, but I just want to add something. That rockets you were mentioning uh, exactly uses the pressurized vapor, right? Water vapor.
oh, what?
Pressurized water vapor.
Oh, no. I think they had a class for that as well. But
Oh,
when I ended up going, we used, and I can grab one.
yeah.
Um, these, I don't know if my video comes through, but these cartridge type ones, where it's a black powder engine.
Oh, okay.
Now, obviously, they wouldn't let the kids in the class um, load the motors and everything. They would have an adult do that, but you were allowed to do all the gluing together, the build of the rocket, and the painting of it, and got to press the button and everything, which was honestly always really fun. And then when I got older, actually, I ended up um, volunteering at uh, the science museum to be the adult in the class, basically. So I got to teach it and help, you know, younger kids do the same class that I did when I was their age, as a part of my scholarship for school, because we had um, a scholarship based on like volunteer hours and everything. So
Oh, okay. So
as a
can
part
you
of that,
show?
I ran the camp.
Okay, I understand. Can you show the motor again? So Ali, can you pop up the Robert? Yeah. So this black powder rocket you said.
Hmm. Yeah,
That's cool.
it has a sleeve on it that's just glued on, but I think this one, and it has a little tape on it just to uh, prevent it from going too far in. But this one's an unfired one, so this is a live motor basically. Um, but yeah, these are store bought. So we have, and I know you're gonna ask this question, so I don't want to get too far ahead. But we have different levels of rocketry, and the lowest level you can buy at like a hobby store, these motors basically to fly small rockets.
Okay. Yeah. Our rocket. I'm gonna mention later, but our rocket was an M series, and it was like almost 1 meter long.
Mm.
Yeah.
Wow. Yeah, that's a lot. I haven't gotten to work with one of those yet, but it would be very cool. These are this is an F. So
Mhm.
uh the different impulse levels on that is extreme, basically.
Yeah, yeah, yeah. So I'm curious that was your department in university enough to understand the rocket science, or you did get help other disciplines out of the university?
Yeah, so I was kind of late to join the club actually. I started freshman year, but I didn't get to have very much involvement because of the leadership in the club wasn't as like organized or streamlined, so they didn't really do a very good job at bringing the freshmen or the younger students in very well. So I actually my third year, I ended up going back and working with the club again. And at that point, it was a lot more open environment. It was a lot more people I actually knew by then too. So in that class or in that club, uh, they were very good at teaching how to do like the higher speed, higher power rockets.
Hmm.
Because they had one, I think, also 3 meters, just about, that they had flown at competition, similar, and they had that on display, in the window and everything, and then a couple other smaller ones. And the way the club worked was there were different teams, so each team would work on like a specific rocket. So I think at any given time there were about four teams, and working alongside them, I will say it kind of pushed the boundaries of uh, what I knew on rocketry, so that they did have a lot to teach there. But the big one, I think, was just the engineering design flow, because being in those clubs is really really helpful for understanding how to like actually work on a team and a project and make something.
Yeah, you attended the club like we are exactly doing right now.
Mhm. Yeah,
Yeah.
it's a very helpful thing, and I think it helped me get my job, honestly, because I was able to talk about it. The team I was on, I put the um, operations that it does on the screen here, uh, where it would launch and then it would try and do active recovery. So that was like the first real attempt there at trying to do like a kind of like SpaceX, where the rocket
Yeah,
comes back and it lands, but we
the
were going to
Falcon
use
rockets.
yes, yeah, we were going to use helicopter blades instead of another rocket motor. Um,
Yo, oh yeah, and I'm going to go with that and with this subject. So I've just saw some videos on your Instagram page, and you're doing helicopter propeller. You're using those kind of launch system. So is it actually does it actually work?
so it can. I have like a separate thing for flying just that. But I've also used it to test the tuning, because some of my rockets have active control, like my personal ones. Um, so using a propeller instead of a rocket motor is really helpful, because the propeller does all the same things basically as the rocket motor. It makes a little bit of vibration, it generates thrust, and uh, the nice part about a propeller is it doesn't cost as much as one of the engine cartridges, so I can run it all day, and then I mount the rocket into a gimbal so that it can move, and that allows me to test all the rocket systems on the ground plugged into my computer, so I can see the data line coming out. But one of
Oh,
the other things I do have is it will fly on the propeller only, just as kind of a fun demonstration with like an RC controller.
yeah, and as I imagine, they are not also they are also environmental stuff rather than the the powder rockets. So they are good
Uh,
for environments, I think.
yeah, yeah, more so. If anything, it's just it you get longer flight duration, you get a little more control. Um, it doesn't scale up very well, so like to make a bigger one, it doesn't really work the same, because like a rocket motor of the same size can move something
Yeah.
that you would need like twice the size of propeller for. Um, but for small things, it's pretty viable. That was kind of the thing we found with the rotary rocket here, where it had the helicopter blades. Was the blades need to be like bigger and bigger and bigger the more heavy
When
the
the
rocket
rockets,
you're working
yeah,
with is.
increase the size. Yeah. Uh, the reason why I asked this question, because I've watched some presentation, uh, some Elon's presentations, and he said that
Mhm.
we are not we won't be able to build the rocket with electric power. So, what do you think about that?
So that is pretty accurate. Getting off of Earth is really difficult. Um, the uh, the majority of the focus as of late is in trying to get things as light as possible. So that's kind of the interesting part with like where things seem to be going right now. It's less like build bigger and bigger, bigger things, more can we make something we already have smaller? And we kind of already see that with like cell phones. They just kind of seem to get a lot smaller. A lot of electronics go that way. So if it's smaller and lighter, you can do more with it. Um, so a lot of the time, the focus is less on the rocket going up and more on getting the thing that the rocket's carrying lighter, so that maybe one rocket can carry like 10 satellites. And I think 1 week ago, just out at the Kennedy Space Center out here, there was an Atlas 5 launch carrying multiple satellites in the STP-3 mission.
Mm,
So
okay.
that's a good example of like technology being miniaturized to the point where maybe like 8 to 10 satellites can all ride on the same rocket, and then you kind of lower the impact per launch. Um, One of the other things too, like with my company that I work at now, Sierra, um, we want the facilities that you make things in to be green. So the whole idea going forward with us is like if we're going to build a new building, we're going to try and do like zero net carbon, and that goes down to the process level too. So like making a solar panel, like what goes into that, what's the carbon footprint of that, and how can we make that a little more sustainable.
Oh, okay, I understand. So,
Hmm.
and I just want to continue with certifications, model rocket certifications in the United States. And in my country, it's a new thing, and
Hmm.
it has been like 5 years or more. More,
Hmm.
yeah. But it's a new thing, and we don't have this kind of certifications. So, can you tell us about certifications in the United States?
Yeah, I think I have the words for how it works and everything, so I don't misspeak. But we have two organizations here, the National Association of Rocketry, right there, and Tripoli, and both, even though like they're in the United States, they also have chapters all over the world, basically.
Hmm.
And the the cool part about it is it's a pretty tight knit community. Everyone kind of works together, and they want to see it grow, basically. And the way it comes out is there's three main levels, but there's technically four. Um, Level 0 would be low power. So low power is anything below, I think, 100 Newton seconds of impulse. So this rocket motor here is level 0. So it's low impulse. It's a slow burning propellant. So all the black powder motors are uh, low impulse and low burning, so they fall usually in 0.
Okay.
And then you get into level 1, where it's higher impulse. I think it's um, over about 150 Newton seconds, up to uh, I think almost 1,000. And
Okay.
it's and I think they missed G here in the alphabet, but it's like HI and G falls into there. So those impulse levels are just increasing impulse up to that stop, and that's just being able to fly high power rockets with bigger motors, and each level you go up has more requirements that you have to meet to be able to be certified. So like level 1 is generally easy. I have a level 1 rocket over here because I have to recertify myself due to the fact that when in university, my paperwork apparently was not signed off by someone. Even though I was at the launch, I did all the steps and everything to get certified. But the main point is you show that you're adhering to the safety codes and the procedures, and you're doing everything in a safe way. And that goes for each level of rocketry. So J, K, and L in level 2 are larger, and then what you flew is a level 3. So that is the biggest of the big that you're allowed to fly. So that's M and O and beyond, which I think beyond is called a P, and P is experimental, so it's anything that's non-commercial and not off the shelf, built by any other company. So if you were to build a rocket engine at home, which I don't usually advise unless you really, really know what you're doing, um, then that would be in the P category, and that to fly at a like an event or a club place, that you need to be level 3 certified, and you have to do each one in order, basically.
Okay, I was gonna ask this question.
Yes.
Can you get back to the
Oh, yeah.
last? Yeah. So is this certification, is this level includes the active systems or just passive systems?
So that's really, really interesting you asked that. There's a there's it's an old club in the United States. Like, it's a very old type of hobby and club. So a lot of the people um, doing it are a lot older. So there's not a lot of that going on right now. So a lot of the people doing the active control, like with my avionics system, um, that's all brand new. So there hasn't been a
Can you show
real.
it closer?
Oh, sure.
Yeah, that's great. That's awesome.
So
I love
so
it.
this is supposed to go in my my high powered one as a data logger, but it's the same thing that controls the other rockets. So it's like a circuit board, basically, that I've come up with um, to do the control. It's very simple. It's kind of like a drone controller, but it logs the data and everything. So that works for doing a level 2 rocket, actually, because level 1, all you have to do is demonstrate, and I can go to the next one here. You just have to demonstrate that you're over 18 years of age. You can uh, you can get certified, so you've like paid the membership fee to the organization. um, you have a card that they send you when you're a member. I think you pay about $90 a year to be a part of it, and it gives you insurance. So, like, if your rocket were to come down and break something or someone's property, you're insured, basically,
Okay,
by
so
adhering to it.
that's a big thing, guys. I think.
Yeah.
So
You have to fly at their launch sites, so it has to be like for NAR and NAR, you have to be you have to fly at their specific places. So you can't just fly anywhere. You have to go to an event, and they usually schedule those in advance, and you can talk to people. Um, the motors for like a certification attempt are usually established. So they have to do like an impulse between like two numbers, and then your rocket has to have a weight between two numbers, basically. So for
mhm.
level 1, I think it's between 250 and 120 newton seconds of impulse. So they suggest some motors there, and then the other thing too is it has to be under 1.5 kilos um, of overall mass. Uh, and then I think there's a couple other things, like it can't be mostly metal. It has to be like lightweight materials like cardboard, wood, fiberglass, and then you have to get it back. So to be
Yeah.
certified, you have to show that you can do the whole process. So it starts like on the bench where you have a rocket with no rocket motor, and you have to talk through like how you've built it basically to a person who's already certified at level 1, and then they can certify you back um, because they've done it and they've been approved. So the main thing to get certified is you have to have like a place that they will allow like you to launch, which I know there's several of those in Europe, uh, and you need to have a representative there who is also certified. Which once you are certified, you can then be a representative. So there's usually one somewhere.
Yeah,
Um,
I was actually gonna ask about this topic. So, what are the advantages if I certify it?
So I don't know how it works in other countries, but the way we have things set up is if you were to go on the internet and try and buy, I'll go back. Let's say an H motor, you can't. Um, they don't allow anyone to buy a rocket motor without reaching this certification. So if you
It's
wanted to
more
go to
like
the
fun,
store.
right? The level one is I as I understand, it's more like fun.
Yeah, yeah. It's all it. Most of it's like people who just um they just enjoy it. They want to have it as a pastime. So like level 1 is what like the biggest group of people. People at the university level are usually closer to 2 and 3.
Okay.
So in those cases, they usually have to have a representative come out who is level 3 and look at what they're about to fly. Universities also get some special exceptions too, because they are universities, which is always nice. So, like the competition rockets are usually a lot larger, but um, they usually have like a mentor or someone who uh, comes over and at the competition make sure that they're doing everything right, because they're rockets, they're full of explosives, they are dangerous. So
Yeah.
there's always someone making sure. But in the United States, anyone can buy an M class motor or an N class motor if they meet the criteria of all of this. Um, there's a good example of of like the level 3 process um, on YouTube actually. If you're familiar with BPS
Yeah,
space,
yeah.
he
I
yeah
almost I watched all of his videos. So
yeah
he's also a good engineer and he's doing a great job.
yes yeah he's great. And he has a
And the
video
other thing
showing
is
an
that
O.
I saw some photo with him with you in your
Oh yeah,
Instagram page.
yeah, he actually he came to my area and I was able to hang out with him for a little bit. And uh it's kind of a nice part about working at the Kennedy Space Center, because a lot of people come through, so you get to see a lot of interesting people. Like I think we had um last month or the month before, like some people from the French government come through and tour the facilities. But um, Joe from BPS, he was able to come by, and um, he was there to see a launch, so I just was able to go meet up with him. But he attempted to get certified on an O class rocket, and that has a lot more like these requirements for minimum requirements. It has a lot more of those, so it's a lot harder to do, where you have to like meet all of these requirements, and some of them are very hard to meet. Um,
So
and
like
the
when the level hires, I know
mhm.
that you have to deal with other facts, other flow facts like shock wave or the other
Hmm.
things about avionics. So it's getting harder and harder when you go up to another level.
Yes. Um, the whole idea is like to prove that you can do this all safely, even with more complex rockets. You can go in and uh, point to things and prove that this rocket is going to fly safely, and then when you do and it successfully comes back and lands, then the person reviewing you, it almost like it's basically a test. They can say this person knows what they're doing. I trust them. They can buy these and they can do this on their own without anyone basically saying it. So when you would go and fly like another rocket, you don't have that person monitoring you and like reviewing you to make sure you're okay, because you're now trusted to do it right.
Yeah, okay, yeah. And you become, I can say, the master. Like,
Yes, yeah, exactly. I know a couple people, actually, one from Croatia and one from Poland, and I think this past month there was a competition, I think in Poland, for university level rockets, and they both got certified because there was an NAR representative there, and they had built a rocket to fly at the event. And I think, and I might be wrong, but I think that those representatives had flown over from the United States to certify a bunch of people, and some of people are retired and they just do this, and they went over and made sure that they can all be certified. And now, because they know what they're doing, they can grow the community and have more people, knowing how to do this, in Poland, Croatia, wherever, and all the other people who were at the competition too. So it's really cool because it just kind of grows.
yeah. So, is it possible if we want to get a certification from these companies you mentioned? So, do I have to be American, or all over the world can the people all over the world can get the certifications?
Everyone can. So, like I was saying, they were from Croatia and Poland. So, um, they they their only um, goal basically was to become certified so that they can participate in launches at these uh, clubs. Um, the nice thing is, in the United States, we can just buy some of the things. But I know in Europe things are a little different based on where you live and uh, what country and the rules. So I'm by no means an expert, but I do know that at like sanctioned events where it's a very structured event, you as a hobbyist can go and purchase a rocket motor there and fly it.
Yeah,
For me, I can buy it online and have it shipped to me even, and fly it at an event. But the idea is, once you're certified, you're trusted to know what to do with it and go do it. So I know like hobbyists in Europe will tend to build, and then they will go and they'll meet and they'll fly at the site, and um, it allows it to grow kind of outside the university level. But
no,
being university obviously makes it a lot easier because you can fly way bigger rocket than like I can.
okay. So that's great. That's the great thing we have to be the opportunity we have to think, right.
Hmm.
Yeah, I just want to remind for audience, if you have any questions, you can write comments, and we are going to discuss in the end of the event. So I just want to pass to the some popular subjects in rocket science.
Hmm.
So The first thing is that uh, can you tell us about the evolution of the rocket motor in the future and what type of motors ought to be improved to be able to reach the long distances?
Okay, so there's one challenge that's like really big with like space propulsion, and that's the weight and the
Yeah.
efficiency of the motor. So there's different ways to approach that. um, sorry, one second. Okay, so there's two different ways to approach that, but it all comes down to speeding up the exhaust velocity. The biggest thing is getting the exhaust velocity faster out the back of the engine. Um, and the faster you can make the exhaust velocity, the more efficient you can make the rocket motor.
Yeah.
Um, the two main things that are being looked at right now in the world are nuclear thermal propulsion and electric propulsion. Um, Electric propulsion and nuclear thermal and normal chemical rockets like these, um, or like the Raptor engine or Merlin engine or Vulcan engine, all the large bell-shaped nozzles. Those all are very different things. So when we see a rocket launch, it's with a usually pretty inefficient engine, but it's very high thrust. Um, if you go to a nuclear engine, it is a little lower thrust, but very efficient. And then electric is very efficient, but very low thrust. So they work in different applications. So there's all sorts of different um, nuance to which one you would pick. But the big field of study lately has been nuclear propulsion and electric propulsion to make those better because they're very, very efficient and they can go a lot farther depending on how good you can make things. So for Artemis, actually, um, there's there's the Deep Space Gateway, which is that international lunar space station, and Deep
If
Space
you
Gateway.
sorry to interrupt, but if you have a photo, you can show
Oh,
on
sure.
presentation.
I think I do. Um, the Deep Space Gateway though is uh, kind of dependent on. I don't actually have one, oddly enough. Um, it's a space station though, and it has 4 ion engines on the back, and
Okay.
those ion propulsion electric motors, they're able to propel the station. They don't push it very hard or very fast, but over time they can be on for weeks to months at a time, and they can change the orbit of the vehicle. There's a lot of people doing a lot of work on those. So the university level research on those is amazing because they're the ones who are really kind of pushing things forward. Because there's it, there's not a full understanding of what works and what doesn't right now with ion propulsion. So uh, new concepts come out all the time, and new adjustments basically that make it better uh, are always coming out, or smaller too. Like I was saying, there's ones that work on CubeSats where it's about that big, but it's a propulsive engine able to propel the satellite. Um, those allow you to go very far and in theory very fast. So you could do a Mars mission with very, very large solar panels and a lot of those ion propulsion
Perfect.
systems. The other end of that is nuclear, where you're using a nuclear reactor basically, and you're putting propellant into that, and the fuel heats up when it comes in contact with the reactor, and then it goes out the back as exhaust. Um, that has
Is
a
it more like
downside.
is it more like a sun collector where we products where we have the energy, electric energy?
Um, kind of. If you if you are you referring to those where the sun is
Yeah,
reflected? Yes, yeah, it's like that where it gets very very hot in a small point, but it's a the nuclear cylinder basically.
yeah, okay,
Um, those are really good because they have high efficiency and high thrust, so they can move a lot of cargo uh, to and from a place. So my company, Sierra, again, has a development project with DARPA, which is like a U.S. government development organization that just sends out like grants to go develop an idea to a certain point. Like they don't necessarily have to fly something sometimes, but develop the concept. Um, but for this one, we actually have to make the a spacecraft and fly it. Um, and it's a nuclear spacecraft that has a liquid hydrogen fuel and then a nuclear engine, and it's able to push uh, payloads around. And the whole idea with that, which comes all the way back from the 1960s, is using the engine because it's so much more efficient. You can do multiple missions, so it's almost like a taxi where you can drop off.
space taxi, I can say.
Yes, yeah, you can drop off your payload, and then you can come back, and you can grab another one, and you can go back out and come back and do that without having to launch a new rocket. And that gets back to that uh, sustainability thing of uh, being able to launch less and do more with the same amount of launches. And then there's the same type of thing with electric propulsion, where it's the ion engines, but you get there a lot uh, later because it takes longer to go anywhere with that because
Okay,
it's slow to get up to speed, but it gets there eventually, basically.
yeah, yeah. Those are the things that are waiting for us in the future.
Yes,
Yeah,
very
the
very
perfect thing.
close.
Yeah,
There's actually in the United Kingdom, I know, and I think also in Germany, um, two nuclear propulsion companies that are working on engines right now for that. Um,
okay. That's great. That's cool.
mhm.
So, when do you think we'll start to see the rockets containing the life area, like we see in a movie, like Passenger? So
You
you
mean
have you watched the
like
movie
rotating?
Passenger?
I
Yeah.
actually haven't.
Oh,
I know it. It's got like a. I think it has a spinning spacecraft, right?
yeah, 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 yeah. Exactly.
So um, that I don't know exactly when we would start to see that. Spinning is really hard to deal with, just because you need to be big for it to not be uh, a carnival ride. So like I don't know if you've ever been on one of those carnival rides where it spins
Yeah,
and
yeah, yeah, yeah.
you get stuck to the wall basically. Um, those if you if you try and move your head around too much, you can get dizzy or sick. And that's just because it's not very big. So having a bigger diameter means that you don't get sick because there's not as much of a difference between your like head and your feet.
Yeah. Like we are
Um,
standing on the earth and we don't feel anything.
yeah, yeah, exactly. So like having a very large spinning ship like in that movie that works. But right now because we have to build things that fit inside the fairing of rockets, it's a lot harder. So I think we'll see spinning spacecraft like in the near term, maybe like 10 years, but in like smaller, more demonstration type things where maybe it's a CubeSat to test out an idea, or um, it doesn't do full gravity like on Earth, but lower gravity. One of the NASA proposals for a Mars mission is called Copernicus, and it's a nuclear thermal propulsion rocket where it's very long and it rotates like a bar. So
Yeah.
So like this, instead of like a large ring, like
Hmm.
we're kind of used to seeing, but because it's rotating, the acceleration is outwards, and it kind of makes it so that there's a floor at the bottom of the spacecraft. So it's almost built upside down, the way the floors go, but it allows you to have some gravity during long trips. So that's probably the closest thing that we'll get in any near time to that
Yeah.
type of vehicle.
No, that's the great thing I see. So, the people make memes about what you said earlier. Like, we don't, we feel so excited when we go to the carnival. You know, like you said, the big
Mhm.
wheeler things. So, but we don't feel anything standing on the earth. So I see some memes on Instagram. The people made. You know.
Yeah, no, it would be very uncomfortable if the ship isn't big enough to where it would be a very bad time.
Yeah.
So, guys, Robert, and I know the time we agreed with you is done, and I know you have called. Maybe this station is a little bit hard for you.
No,
And
I can keep going
So
actually
okay,
okay,
if you want.
and
that's great. That's great.
okay, I just
That's the thing
say
I just want to ask.
I just say something. We have some comments that they are asking you some questions. If you can answer them, I
Oh
can
wow.
show it on the stream.
I think they're actually up on the right here.
Yeah.
Yeah.
Okay, I can go to the top, I guess, and see questions are answered.
Did you see Rennie's one?
Yes, yeah, I just got there. So
Okay.
you said radio wave sources will affect the system, might start a fire, or give wrong commands. Um, so the system is designed in a way that prevents radio waves from getting in, but it's kind of a paranoia uh, to prevent anything from happening. It's kind of one of those things where the the area is set up to be able to reject electromagnetic waves. The building can reject electromagnetic waves. The rocket is obviously going to fly outside where there are electromagnetic waves, cell phone towers, radio towers, what have you. Um, but um, the the consequence for not the consequence for something happening is so high that everyone's just very careful around it. It's one of those things too where leaving your keys in your phone also helps because in one of those type environments you don't want to drop things. So like pieces of um, lint or things in your pocket, a keychain, things like that. If they drop, especially because the rocket's vertical, it can fall between cracks and fall down the side of the rocket and either hit someone, get stuck somewhere, and that's just not a very good time. Just because you can halt a launch, you can break things, you can hurt people. So even though even though it's usually just fine, um, they don't know what could be coming into the area, so they're very very careful. Um, One of the other things too is devices are allowed in the area, so um, there's like an approved list of devices to go into it. So like when I had gone, we had an approved camera. So it was a digital camera that this is the designated camera if you are going to go take pictures next to the rocket or of the rocket, and this is what you need to use so that someone doesn't bring in something um, that no one's had a chance to look at or anything. So it's for one an organizational thing. It's probably a little over um, conservative, but it does help. Um,
And the other question is from Serjan. Did you see?
Yes.
Can you?
How does the mass of a rocket affect motion? So the more mass you have in the vehicle, the more you have to move. So it's almost like if you're going to have a backpack and you're going to load it up with supplies to go on a hike, the more you're going to carry, the harder it's going to be to make it to a destination in a given amount of time. So you're going to have to work a lot harder. And it's the same thing with rocket engines. So everyone's always trying to get the weight down and the mass down because it makes the engine have to work less hard. So you can either go farther or you can have a smaller engine, and that keeps the cost down. So for ion engines, they are um, they're really low thrust. So if the vehicle is very heavy, then it can't push it very hard. So it's going to take longer to get to its destination, and that may be fine, but um, depending on what your satellite or your spaceship's going to do, that may not be fine to where you now want something lighter. One of the other things too is you have to be able to get off the ground. So if it has enough thrust force to counteract the weight and go up, then you can actually take off. And to circle back to the propeller topic we were talking earlier, the smaller thing that I want to fly on propellers that uses the same thrust vector control and circuit boards,
Yeah.
uh, it has to be very light, and that's been a challenge because the propellers only can push so hard. So I need something light enough um, to carry everything that it needs to fly, like the battery and all the systems, but also uh, exist and do the job. So it's a real challenge there.
So the third one, did you see the Edelgins one?
Yeah, I just got there. So we fly an M motor in the competition, so we can pass first two levels and get level 3 certification. I'm not actually sure if it works that way with university. Um, if you were level 1 and level 2, I think you can then get your level 3 by using the M motor. Um, but the way our university had done it was they tried to stay slightly lower impulse levels. So we tried to fly level 2 mostly, and then one person was trying to get a 3, but I think they graduated before they got the opportunity to get it on the rocket that they were working on. Um, you you get to bypass it in the sense that you got to work on a rocket that's an M and fly it, but you don't get to bypass it, and you can't buy the motor potentially. But um, that's kind of a weird gray area that comes with being university versus not. Just because now you have access to all these things that you wouldn't normally have access to because you're a team, not just one person.
Yeah.
Um,
The thing is actually works the same in my country. So as I mentioned earlier, we attended the competition, the rocket competition. But in the first, we didn't have the motors, and we just designed the motors, designed the rocket, full rockets, the avionics, and the deployment systems, and the outside of the rockets, the
mhm.
covering stuff like the light tubes. So, but in the end, the competition gave us the motor, so we placed the motor in the rocket, so it launched. So we didn't
Mhm.
have anything with rockets during the competition. So in the
Mhm.
end, we took it. We have it. We had it.
Gotcha.
So I have last question. It's about the avionics because I am a coordinator of avionics for,
Mhm.
of our team. So I need to explain something to you. I will not know anything about avionics, and I'm not a programmer or computer engineer.
Mhm.
And last year, when we start to prepare to competition, and my friends say who will do avionics, and I said, if there is any volunteer, may I can be a volunteer, and I
Mhm.
start to work on avionics, and I learned something about avionics, like using Arduino,
Mhm.
and like creating a circuit board and something like this and programming it. So the in the competition and the with my circuit board, there is a one problem. The datas and the things that like I want to take from the avionic card to ground station, they were not coming directly when I want. It
Mhm.
just it just the data was breaking down every second. It just like, how I can explain you, I don't know. The when the how I can say, uh, when the component sees like it's true, when it calculates it's three, I think the sending message was like two or something like this. And every time I see this, and this year we will change the things from the circuit board, and I don't know anything about STM, TNZ, or any other things like Raspberry. I don't know anything about them, and this year I want to use more effective mother card. Like already I understand, I think. Do
Mhm.
you have any suggestion suggest to it?
If I hold this up, this is my own board, but
Okay,
it's
you
a
made it,
teen.
yeah.
Yes, yeah,
Okay.
yeah.
That's
This one doesn't work, but this one does. That's in this avionics stack.
Okay.
It's the same thing, but attached to something. Um, but it uses the Teensy. So I just found the schematic for the Teensy online, and then I
Hmm.
built that on a board of my own so that um, it's just a little smaller and it has everything I need. But I think the Teensy is a very very good platform if you want to work with that because it works with all the Arduino
Okay.
code base, so you can use all the Arduino, but it goes way faster. It's uh, it's very forgiving because it is there's a lot of information on it. You can buy it pre made too,
Hmm.
if you want to have the whole thing, or you could buy all the components and assemble
Okay.
them.
Hmm.
Um, and
Which one are you using? The 6.3.6?
I think my rocket over here uses a 3.6. This is a
Okay.
3.2 just because it's a little smaller, but
Okay.
overall everything's basically the same between them. If you want to use the data logging, I think the 3.6 might be a little better if you just want to buy the board and then have it plug in and use it that way. A
So
lot of people use that, and that's what I use over there.
I think this year we are gonna have some more places, because last year I will not have much place to put avionics inside,
Hmm.
so it was so hard to do for me.
Hmm.
And may I can show you my avionics?
Yeah, of course.
Okay. This was mine payload avionic,
Hmm.
and there is Arduino and RF and GPS module inside it.
Oh yeah.
So we didn't find our main avionic because it just fell down so fast.
Hmm.
There was an avionic soup inside the earth, so we didn't find anything. And this year we will do a better one with our how I can say, with our experiences. Sorry for my
Gotcha. Oh no, it's okay. You guys have done great English, honestly. So um, the uh, um, the hard part is always the avionics and the software, I think. Like,
Yeah, this
So
is the
that's why we
reason.
give the
This is the
responsibility a lot.
reason why the other members didn't choose
Yeah.
avionics.
uh, so from my experience, I wanted to build, these active control rockets, and nobody told me that it was all electronics and software, and those are like my two worst things. So it's a lot of like, um, how would you say, like wandering around in the dark, trying to feel your way through
Yeah.
it. Um, to where like I said, this one doesn't work, but I went through the entire effort of building it only to find out that the board it's built on just doesn't work. um, uh, and it took me a while to figure it out, but it's one of those things where like the more you do it and the more you understand it, like by just doing it, you get very very good at it. And doing this at home, I didn't get to do this in university really, so it was a very big learning experience,
Yeah,
and uh, it gives you a little bit more freedom. And that's one of the things that I've been kind of considering going back to my old Rocketry club to be like, hey, how are you guys doing? Even though it's all new people now, I don't know anyone there anymore because it's been several years. But that was always the thing that I remember everyone struggled with, because you go through school and you have to do all your classwork, and you have to do your tests and your exams and everything, and then on top of that somebody's asking you to understand how to make a circuit board. And it's
yeah,
like just trying to make it all work. And it's taken about 3 years to get to this point, and
Wow.
well, to this point where
yeah.
it actually
That's a
turns
great
on.
effort I can see.
Yeah. So
So
I
actually, I was gonna ask you the about the most challenging parts uh, when you build a model rocket, but I already got the answer. So like you said, it is in a avionics, right?
Yeah, the avionics is the entire thing. Here, if I step out of frame for a second, I can grab a couple things actually.
Yeah, yeah, yeah. Oh man, that's the great.
So,
That's the great thing I just saw.
oh yeah, I'll bring that in a second. So, you aren't really, doing it if you don't have a bag of your failures.
Yeah,
um, so I have many of those. Um, like
Yeah.
say it's probably the same board exactly that you have, but this one, I think this one actually it it worked, and then it mysteriously stopped. That's always how it goes. It
Yeah.
works. It works on Monday, and then on Friday it just stops working, but you didn't do anything different. Um, so I had made one of those, and you can kind of see the progression. And then this one, um, the light comes in just right, where it's got some soot on it. But this was kind of my first ever circuit board, where they manufacture it out in China, and it's the same thing: Arduino, and then GPS, and then a barometer here. So that one flew a couple times, and then I went to this one, which uses the teensy, like I
Okay.
said. So it's right here, and that's what's inside this. So this has a circuit board inside there, um, just like this, with all those electronics. So um, it's it's a long way to go just to
Yeah,
get something that works well, and you're
I can
always kind of
imagine.
fighting all the the problems, and it's an uphill climb, but eventually you get to a point where things mostly work.
Yeah. So
um,
the thing is that I watched your video on Instagram, and
Hmm.
the rocket you made, the I can say the model Falcon 9.
Hmm.
Yeah,
Yeah, this
this
one.
one. Yeah, it launches with the active systems, but it's not land with them yet, right?
Not yet. I'd like to try that, but I'm a long way from doing that. So it has a parachute
Yeah.
in the front up here, where everything stores, and it deploys it. I probably don't have the sun coming in the right angle. It's like
Yeah,
not
I can
not
actually see.
helping. But yeah, it has a an engine mount. I can stick this one in here. So it's able to angle its engine to point and steer.
So it
Um,
adjusts the stability of the rocket when
yeah,
it flies.
the best way I've ever found to describe how it does it exactly is if you've ever had a broom and you put it on your
Yeah,
hand and you balance it and you try and stay under the broom. That's exactly what it's trying to do.
yeah,
So um, it's it actually it does better the longer it is, because the weight is up here and it gives you more time. So like if you try and balance a small object versus a big object, it's a lot harder.
yeah,
So having like a long thin rocket
yeah,
works a lot better.
yeah. And okay, I just want to say thank you
yeah.
for all this meeting,
Oh
and
yeah, of course.
in this year we are gonna have a project to plant trees in
Hmm.
our location, and when we do this project, we are gonna plant one of tree for your name
Oh,
for thinking about this meeting.
oh, thank you.
Yeah. So, again, thank you for participating in this meeting, and we are so glad that you accepted our request.
Oh,
So,
of
the
course.
other thing is that are you currently living in United States? The which state exactly?
So if you know where Kennedy Space Center is, it's in Florida. It's at the tip
Yeah.
of the bottom,
So
by
yeah,
Disney World.
yeah. Some of my friends, includes Ali, is going to travel to the United States this summer with a
Mm.
program of work and travel.
Yeah.
Have you heard?
No, no. Are you like an exchange type thing,
Yeah,
Something
or
like that, yeah. The
yeah,
exchange.
something
So
like that.
you go to the United States and you work around 3 months, and after that you go traveling across the country.
wow?
So yeah, I did it 4 years ago, and I was in Massachusetts.
Hmm.
Yeah, and
And
Ali and
I'm
the other two of my friends is going to go to the United States. Maybe I was just wondering if they can meet with you in there.
So there is the visitor center, actually, the Kennedy
Yeah.
Space Center Visitor Center, and it has like the space shuttle, and the Saturn V from the Apollo program, and all that there. And I've had a couple people come in, and I always say, like, if you go there, I can I can just go from work and meet you, basically. So
Oh,
of course, but
thank you.
yeah, it's a cool place. Everyone always wants to go there anyway, so it usually works out that way. Um, but I had a team from Switzerland that they had talked to me a little while. They were doing the same thing with the vector control, um, and they were having a large, like, university size, basically, tour where they had gone to Kennedy Space Center, and uh, they were going around on the bus where it takes you through and it shows you the actual launch pads where all the rockets are and everything. And I was supposed to go meet them, and and that was a pretty cool day.
Yeah.
Okay, so when I come in United States, may we can meet at Kennedy Space Center.
Yeah, yeah. If you can get there, just always reach out. I'm pretty open, as Barack was able to find.
Yeah, yeah. Thank you again. I'm actually willing to come to the United States, but because of my currency, it's getting harder and harder to go another country. But
Oh yeah,
yeah, I'm so grateful for Alice and other two of my friends that they are going to travel to United States and go to the Kennedy Space Center or the other things.
yeah, yeah. It's cool. I haven't been able to really do much of anything the past year, 2 years almost. It feels like forever. So I think recently we're gonna be actually going on a first trip in. It's actually been like 2 years. So
Yeah, that's
um,
great. So
but
again, thank you for participating. I think we are coming to end,
okay.
and yeah, I just want to thank you that you share your ideas, share your knowledge with us. So thank you.
Yeah, of course. Like I said at the beginning, I love doing this type stuff. So um, I appreciate you guys including me.
Yeah, I have been lots of fun times. Yeah.
Yeah, no problem.
Okay, now I'm closing the stream. Okay.
Okay.
So have a good one, everyone.